Hello, and while we're waiting for the crossword video to upload to YouTube, I thought we'd do a solve with Super Fiendish from today's paper. So without further ado, let's see if I can make this work. Okay, here we go. So as usual, we're going to start by using this notation that we recommend, where we make notes in 3x3 boxes where a number can only appear in 2 of the cells. We see how far that takes us. Oh goodness me, this software is so slow. Just have to use the cursor because it's just quicker. You can see that's a naked 5 there, so let's put that in. Naked 6 there. Naked 6 there. See, there needs to be 6 down here. Oh, in fact, there is a naked 6 there, like that. So this is a 6. We need to place 2, 4 into these 2 cells, like that. Should definitely try and use any occasion we lock boxes like this. We need to make sure that we make full use of that sort of deduction. Okay, 2, 4, 6, 7. You can see we've got 7 of the 9 numbers in this row. I'm looking to place a 3 and a column 3 and a 5. Sorry. Now, actually we can do it because there's a 5 checking the bottom there. There's a 3 over here. Can we use this 5? Rather annoyingly, it doesn't look like we're going to be able to make any notation from this 5. You can see we have to place 3, 4, 9 in this box. And you can also see, I think, that we can get no help from anywhere for the 3, 4 and 9. If I was working on paper here, what I would be doing is making some note to show that these 3 cells were 3, 4 and 9, just to stop myself having to do the thinking about that again. Okay, let's go back. So we can see we can put an 8 in these 2 cells here. 7s are locked in the middle cell like this. There's a naked 8 up here. Let's just put a couple of 8s like that. Now, again, some people's notation would allow them to write 4 and 7 somehow in this cell, because this cell can only be a 4 or a 7. But we don't really recommend this. I mean, on paper, again, I'd really like to record the fact that I know this is a 4 or a 7 somehow. In fact, this whole row, whole column is extremely restricted. But the Thomas Snyder method of notation won't allow us to make that deduction or to put those notes in, and if we do, we'll have to remember that this column is sort of outside of the notation being used in the rest of the puzzle. So what we could do is go 4, 7 here, 3, 4 here, and 2, 7 here, I think, like that. And the interesting thing is that by doing that, we can isolate the fact that there is a hidden 3 here. So you can see the 3 here is checking this cell, the 3 here is checking this cell, and the 3 here is checking this cell. So I don't know whether that's an advantage or not, but let's put the 3 in and carry on anyway. So now we can see an advantage of the Thomas Snyder notation. So we've just seen a disadvantage of it, which made it hard to spot this naked 3. Now we're going to see an advantage of it. We have to put a 3 into these two cells here, like this. And we can immediately see, I think, that we now have a 3 and an 8 here, and a 2 in this cell. But due to the logic we're using, we know that this 2 now cannot go in this cell. If this 2 goes in this cell, well, we can't put the 3 and 8. We can put one of the 3 and an 8 here, but we can't put the other 3 and 3 or 8 anywhere else in the box, so that will break the puzzle. This has to be the 2, therefore. And that allows us to place a 2 in one of these two cells. And here's another advantage. We're starting to make efficient progress now. Let's just have a look up here, these two cells. So you can see again, we've got two 2's here and we can place 2's here. And this I think is the biggest advantage of the Tom Snyder notation, apart from the sort of chaining logic and being able to fill in a lot of cells very quickly. It's spotting this sort of pattern. So let's just take a look at columns 7, 8 and 9 in the grid. You can see we've locked 2 into these positions in this 3 by 3 box, and we've locked 2 into the same columns of this 3 by 3 box. Now it should be obvious to everybody, I think, that this cell can now not be a 2, because the 2's in column 7 and 8 are already taken, if you like. They're either going to appear, they're sort of making an X shape. I mean, X-wing is a word that you may have heard in the context of Sudoku solving, and this is a form of X-wing, because the 2's will either appear on this slant of the X, i.e. there'll be a 2 here and a 2 here, or on this slant of the X, 2 here and 2 here. But they won't appear anywhere else in this column. Therefore, they can't appear here. And this has to be a 4, and this has to be a 2. And that I think, is one of the great advantages of using this sort of notation. Spotting this sort of X pattern becomes second nature when you're using this notation. And using notation where you were filling in, we looked at these sorts of cells where there was a choice of just 2 numbers to go into these cells. You can do that, of course, and it is useful information, but it wouldn't help you spot what we've just spotted there. So now we've locked the 4's in here because of this 4, and that means this has to be a 4. And that means that we're only left with having to place a 7 here. 7, 7. Now Tom Snyder's notation comes in again, because this 7, we've already done the thinking that allows us to place the 7 here. And one thing we also have to remember when we're solving is we lock the 3 and the 8 over here and this 2, but now we need to make sure we go back and record the fact that we need to place a 5 in this box still, and that's going to appear in one of these two positions. And that helps us down here because we can place this 5 now. Okay, so now I'm looking at this. This is a very restricted row. Is it going to yield anything? We've got 4 and 8 to place. You can see that we can't quite put anything in. Again, we have to sort of try and make a mental note here about this 4 and an 8, because our notation doesn't allow us to record it. You can also see, okay, so this 4 here checks this cell, and therefore the 4's can be isolated to these two positions. and therefore these two positions too up here. Similarly, this 9 checks this position, so we can lock a 9 into one of these two positions, and therefore one of these two positions too. And so into one of these two positions. And now you can see this square. And this again, I mean, this is one of the problems with speed solving Sudoku, is that there isn't an element of luck in it. You can see at the moment I've got a lot of rows and columns here that have a lot of numbers in them, and then, you know, we're trying to scan as quickly as we can to try and find this sort of cell, and it's really a matter of luck, I think, as to whether you find it quickly or slowly. So you can see that this row here needs a 5, 7 and a 9, and here we have a 5 and a 7 checking that position. Now, so this has to be the 9. You know, and I don't know that I have a good way of saying to you as viewers, you know, how to spot that 9 more quickly. I think it's, as I say, it's a matter more of luck than judgment. Obviously, if you get very, very quick at scanning rows, you can do it quicker that way. But how to find that it was this particular 9 that was the sort of hidden single, I don't know. I don't know if there is a good method of isolating that sort of thing. But in fact, we can see that when I put the 2 7s here, I'd missed this 7 here, so that would certainly have helped a little bit. I've got 5 here. 5's going to be locked over here. That. Now again, just this same column that we found the 9 in, now we can actually, there is a hidden 8 in as well, because this position is checked by this 8, and this position is checked by this 8. Therefore, the only place an 8 can go in column 4 is in this position. Let's fill that in. Locks an 8 down into one of these two positions. And here's something a little bit unusual happens. Let's have a look at this 3x3 box. You can see that we've been strict in using our notation, so we know that every note that we've recorded in these 5 cells is indicating that the number can only appear in one of the two positions. Now let's look at, because we've still got to put notes in this cell, 4 and 9. Let's think about whether we can do that. Well, 4, no we can't. 9, no we can't either by the strict logic. However, 9 is checking this position. Let's see up here, this 9 is forcing us away from this position. The 9 is going to be in one of these 5 cells. Well, it can't be in this one, all right, one of these 4 cells. And that actually is enough information for us to place the 4 here. And the reason is that we have here 5 cells at the moment with 4 unknowns. But once this 9 checks this position, the 9 will be in one of these 5 cells, so it will give us 5 cells and 5 unknowns. Well, if there's 5 unknowns and 5 cells, you know, no other number can appear in these 5 cells. And therefore the number that we haven't placed yet, the 4, has to appear here. And that will break the puzzle. That, in terms of, that's going to be the critical step. You can see now everything immediately starts to flow, and the value of our notation also is clear, in that we can immediately just write in a whole load of numbers just from the logic that we've recorded already. 8, there's an 8 in down here, like this. Let's remove the 8 there just to make it very clear. Now we need to place a 4 into this middle box. See, that can only happen in this way. That forces a 9 into this column. Forces this to be a 9. There's no thought involved in this. All I'm doing is following the notation that we've already recorded. And again, this is one of the reasons that this is that we recommend this sort of notation. Down here again, I don't have to do any thinking. I can just literally write the answers in like this. Here we need a 3 and a 4 now. Let's get rid of this 2 just to tidy it up. 5 in one of these two positions. You can see this 5 here is checking this position. 5, 9, 9, 4, 3, and there you go. That's how you do the super fiendish. A couple of interesting points today. I hope this was worth doing. For those of you who watch the vlogs, to learn about how to solve Sudoku. And we'll see you again next time. Cracking the Cryptic.